Right now, at this exact moment, on Tuesday, the 28th of October 2025, the third confirmed interstellar object ever detected in human history is emerging from behind the Sun after spending 8 days hidden from every telescope on Earth. Yesterday, October 29, it reached perihelion at 203 million kilometers from our star. During those 8 unobserved days, something happened that prompted NASA to activate planetary defense protocols for the first time in history against an object from another star system. The International Asteroid Warning Network, a United Nations-endorsed planetary defense consortium, issued Bulletin MPEC 2025 U142 on October 21 during solar conjunction, officially adding 3I Atlas to its threat tracking list, not because it will hit us, because it displays 8 documented anomalies that refuse conventional explanation, and because the optimal window for any spacecraft to perform a trajectory-altering maneuver using solar gravity assist occurs precisely during perihelion, precisely when we couldn't see it, precisely when it was occulted behind a stellar fireball pumping 33 gigawatts of power onto its surface. Let that sink in. The object designated C 2025N1, discovered July 1 by the Asteroid Terrestrial Impact Last Alert System Telescope in Rio Hurtado, Chile, measures between 440 meters and 5.6 kilometers in diameter, according to Hubble Space Telescope constraints. It travels at 61 kilometers per second relative to the Sun, on a hyperbolic trajectory with an eccentricity exceeding 5, confirming beyond question that it originated outside our solar system. Its orbital inclination sits within 5 degrees of the ecliptic plane, the flat disk containing Earth, Mars, Venus, and Jupiter. Statistically, that alignment is profoundly improbable for an object arriving from a random direction in 3-dimensional interstellar space, where trajectories should be distributed isotropically across the celestial sphere. Here's where it gets interesting. This is not speculation. This is data from Keck 2, Hubble, James Webb, the Very Large Telescope, SWIFT, and 14 other observatories across 6 continents and 3 orbital platforms. The Keck Cosmic Web Imager captured spectroscopic observations on August 24 at wavelengths between 0.3425 and 0.55 micrometers. What they found was a gas plume extending 600 kilometers from the nucleus for nickel emissions, 840 kilometers for cyanide. Mass loss rates 0.9 grams per second for nickel, 3.9 grams per second for cyanide, total volatile loss approximately 150 kilograms per second. The nickel to cyanide production rate exceeds that observed in Comet 2I, Borisov, and sits orders of magnitude above the median for solar system comets. But here's the terrifying part. The nickel emission shows no corresponding iron signature. None. In every known comet, in every supernova remnant, in every stellar formation region ever observed, nickel and iron appear together because both elements are forged simultaneously in the cores of dying stars and expelled in the same explosive event. The ratio varies, but both are always present. Always. Except here. The only environment where nickel appears without iron is in industrial refinement facilities on Earth, specifically through the carbonyl chemical pathway, which produces nickel tetracarbonyl by reacting nickel with carbon monoxide at controlled temperatures, then decomposes that compound to yield pure nickel metal. That process, Ni plus 4 CO molecules forming Ni4, then breaking down to release pure Ni, has never been observed naturally in space, until the 24th of August 2025, when the Keck telescope recorded exactly that spectral signature around an object from another star system. Think of it this way. Imagine receiving a text message, but the alphabet used is one that only exists in human factories. not in nature, not in biology, only in refineries. You can propose that maybe, somehow, under exotic conditions, nature reinvented that alphabet independently. Or you can consider that the message might actually be from someone who uses refineries. That's scenario one. James Webb Space Telescope observations on August 6 revealed the coma composition: 87% carbon dioxide, 9% carbon monoxide, 4% water. Solar system comets typically show the reverse, with water ice as the dominant volatile and CO2 as a trace component. The CO2 to H2O ratio measured at 8:1. Water production rates, derived from swift ultraviolet hydroxyl observations at 3.51 astronomical units, indicate approximately 40 kilograms per second, equivalent to a fire hose, at maximum pressure running continuously. Yet despite this prodigious outgassing, white light images from Hubble and Gemini South show no classic dust tail driven by solar radiation pressure. Instead, narrowband images reveal emission profiles asymmetric in both the solar and anti-solar directions. An anti-tail, a jet of material pointing toward the sun, not away from it, violating the most basic expectation of cometary physics, where radiation pressure drives dust particles outward along the Sun-comet line. Gemini South captured this structure on August 27, a teardrop-shaped plume, 56,400 kilometers long, oriented southeast, opposite the sun's position, plus a secondary extension directed sunward. The coma measured 18,800 kilometers wide. For context, Earth's diameter is 12,742 kilometers. This is a massive, active structure. But the anti-solar component contradicts every radiation pressure model and every cometary simulation built over 6 decades of planetary science. ESA's Mars Express and ExoMars Trace Gas Orbiter observed 3I, Atlas, during its closest approach to Mars on October 3 at 29 million kilometers distance. The color and stereo surface imaging system captured the object as a diffuse white dot moving downward through the frame. Those spacecraft were positioned 30 million kilometers away. For comparison, the Moon orbits Earth at 384,400 kilometers. This was a genuinely distant observation, yet CASIS detected the extended coma. Preliminary data await full processing, but the fact that hydroxyl emissions were detected at that range reinforces the scale of volatile loss. Now we enter the interpretive module. 3 scenarios, ordered by conventional likelihood. Scenario 1, exotic natural comet. 3I Atlas formed 7 billion years ago in a protoplanetary disk around a star in a molecular cloud richer in carbon than our own nebula. Repeated passages near other stars over billions of years depleted surface water ice, leaving a CO2-dominated mantle. The nickel without iron signature results from selective photodissociation of nickel-carbonyl complexes naturally present in the nucleus, where ultraviolet photons break molecular bonds preferentially, releasing nickel vapor before iron compounds can sublimate. The antitail forms when anisotropic outgassing from active regions on the nucleus ejects material in directions not aligned with the Sun-comet radius vector, creating apparent sunward jet. The ecliptic alignment is coincidental, a 1 in 30 geometric fluke given the inclination tolerance. All anomalies resolve to rare but possible natural processes. This is the conservative interpretation. It requires stretching some known physics, invoking conditions never previously observed, and stacking multiple low probability events. But nothing here explicitly violates physical law. Occam's razor suggests this explanation. Scenario 2, directed panspermia, or planetary system debris. An advanced civilization, recognizing that their star will soon go supernova or their planet will become uninhabitable, launches seed ships or data archives toward nearby stellar systems. These objects carry biological samples, genetic information, or digital records encoded in durable substrates, perhaps nickel-based lattices or carbonyl molecular structures designed to sublimate in specific spectral signatures when exposed to stellar radiation. The trajectory aims for planetary systems. The anti-tail represents controlled outgassing to adjust course. The nickel emission is a beacon, a deliberate signal in an unnatural spectrum, intended to attract attention from any technological species monitoring their star. The object is not a threat, it's a message in a bottle, or a funeral urn, or a time capsule, drifting through the galaxy for eons until it encounters a star with planets, at which point it activates and begins broadcasting. This scenario requires intelligence, but not hostility. It fits the data if you accept that signaling through anomalous chemistry is a logical strategy for cross-stellar communication. The carbonyl pathway becomes deliberate engineering. The ecliptic alignment becomes targeted arrival rather than coincidence. Scenario 3. Reconnaissance probe. A mothership, externally resembling a natural comet to avoid detection, performs a high-speed transit through the inner solar system. During perihelion, hidden from Earth-based observation by solar conjunction geometry, it executes an Oberth maneuver, a fuel-efficient trajectory modification made at closest approach to maximize velocity change. It releases smaller probes with reverse thrust capability, allowing them to decelerate and enter orbits intersecting Earth, Mars, or other targets. The mothership continues outbound on its original path, appearing to follow a purely gravitational trajectory to post-perihelion observers, while the daughter craft quietly adjusts course toward planetary encounters. The nickel emission is exhaust signature, the anti-tail is thruster plume, the ecliptic alignment and timing are intentional. This is the low probability, high consequence scenario, the black swan, not likely. But if true, the implications are existential. Here's the improbability stack. Each item individually might be explained. Together, they accumulate. First, the size and arrival rate. The estimated mass of 3I, Atlas, exceeds 33 billion tons. Surveys like Atlas have been monitoring the sky for a decade. To deliver one object of this size requires an interstellar number density of rocky material roughly 3 orders of magnitude higher than the measured density of the local interstellar medium. We should not be seeing objects this large, this frequently. Yet here it is. Second, the ecliptic alignment. Random interstellar trajectories arrive from isotropic directions. The ecliptic occupies a narrow angular band, roughly ±5 degrees out of the full 41,253 square degrees covering the entire celestial sphere. That's about 0.7% of the sky. 3I Atlas arrives within that narrow slice. Why? Third, the timing. Solar conjunction on October 21, perihelion on October 29, optimal Oberth window coinciding with maximum observational blackouts, Earth-based telescopes face elongation limits. Hubble has a 55-degree solar elongation constraint, creating a blackout from September 14 to November 23. JWST requires 85 degrees, prohibiting observations from August 25 to December 9. ALMA radio dishes need 15 degrees, blocking coverage from October 11 to October 30. Only ESA's JUICE spacecraft, en route to Jupiter with an Earth elongation never below 18 degrees, maintain line of sight. JUICE observes on November 4 at 64 million kilometers distance. Mars orbiters saw it briefly on October 3 from 30 million kilometers. Otherwise, perihelion occurred in darkness. Fourth, the chemistry. CO, 2-dominated coma with 8:1 ratio over water. Nickel without iron. Cyanide, enhanced rates. Anti-solar emission geometry. White light non-detection of dust tail. Every single compositional and morphological marker diverges from known comets. Fifth, the activity onset. TESS observations from May 7 to June 3 showed the object bright and active at 6.4 astronomical units from the Sunday. Typical comets activate inside 3 AU when water ice begins sublimating. CO, 2 sublimates at much lower temperatures, explaining early activity but requiring a composition already anomalous. Sixth, the post-discovery pre-images. Archive searches recovered observations extending back to May 21 from Wiseman Observatory, June 14 from Atlas Hawaii, and June 22 from Zwicky Transient Facility. Vera Rubin Observatory captured it during validation, runs from June 21 to July 3. It was visible for 6 weeks before official discovery. It was glowing. It was moving. It was there. We just didn't recognize it. Seventh, the nucleus constraints. Hubble limits the diameter below 5.6 kilometers, but brightness measurements and mass estimates suggest something denser or more reflective than typical cometary nuclei. If the nucleus is compact and metallic rather than a porous ice rock agglomerate, the density implications change everything. We won't know until closer imaging resolves the surface. Eighth, the non-gravitational accelerations. Any active comet experiences forces from asymmetric outgassing, creating tiny but measurable deviations from pure Keplerian orbits. Accurate modelling requires months of astrometric data spanning the full trajectory arc. 3I. Atlas has been observed for 4 months, but the critical perihelion passage occurred unobserved. The IAWN campaign, running the 27th of November 2025 through the 27th of January 2026, aims precisely to refine these non-gravitational parameters. If the fitted accelerations don't match outgassing models, we have a problem. Any one of these could be coincidence, exotic natural variation, or measurement artifact. Any two could be surprising but explicable. 8 simultaneous anomalies shift the probability distribution. Now the timeline. What happens next? The 4th of November 2025. ESA's JUICE spacecraft passes within 64 million kilometers of 3I Atlas and conducts multi-instrument observation using Janus Visible Imager, MAGIS infrared spectrometer, and SWI submillimeter wave instrument. This is the first post-perihelion data from a platform with continuous solar communication. If the object fragmented, if secondary objects separated, if the trajectory changed, JUICE will see it first. Data transmission may be delayed until February 2026 due to current solar proximity and antenna configuration, but ground commands have already been uploaded. The observation window is locked. The 19th of December 2025, closest approach to Earth, at 1.83 astronomical units, approximately 274 million kilometers. This is safe. No impact risk. But this is the optimal window for ground-based spectroscopy, photometry, and radar ranging. Arecibo is gone, but successor facilities and deep space network antennas can attempt active radar if signal-to-noise permits. Surface roughness, bulk density, rotation, state, shape modeling all become accessible. Optical observatories in Hawaii, Chile, Australia, and South Africa will track it continuously. The reappearance date matters because if the object looks different, if the activity increased, if new structures appeared, if the color changed, if the rotation period shifted, it means something happened during perihelion. Late December 2025 through January 2026. IAWN Comet Astrometry Campaign conducts global observing exercise with workshop on November 7, teaching observers to correctly measure cometary centroids and account for extended coma morphology. This is practical training for future interstellar object detection, but it's also a stress test. Can the global network accurately track a fast-moving hyperbolic object? Can we extract reliable orbit solutions with realistic error bars? Can we detect subtle, non-gravitational forces? The campaign targets 3I, Atlas specifically, to answer these questions, while the object remains observable. The 16th of March 2026, closest approach to Jupiter at 54 million kilometers. NASA's Juno spacecraft, already in polar orbit around the gas giant, can redirect instruments for observation. The ultraviolet spectrograph, infrared mapper, and radio antenna will operate. If technological signals exist, radio telescopes will listen. If artificial structures are present, infrared detectors will see thermal signatures inconsistent with sunlight alone. This is the final high-resolution observation opportunity before 3I Atlas exits the inner solar system forever, accelerating back toward interstellar space at asymptotic velocity, crossing Neptune's orbit in 2027, Pluto's orbit in 2028, and fading beyond detection limits by 2030. After that, it's gone. Here's what we watch for. Changes in brightness, inconsistent with distance and phase angle. Spectral line shifts indicating composition variation or outgassing rate changes. Anomalous astrometric residuals implying non-gravitational forces larger than cometary models predict. Optical flashes, radio bursts, infrared excess, fragmentation events, secondary objects. Course corrections. Any deviation from a purely ballistic trajectory shaped only by solar gravity and symmetric outgassing. The November-December window is critical. If the object re-emerges looking exactly as predicted by standard cometary evolution, behaving exactly as models forecast, following a trajectory computed purely from gravitational forces and symmetric volatile loss, then the anomalies reduce to exotic natural chemistry in an unusual interstellar environment. Weird, but not threatening. Fascinating, but not paradigm shifting. We catalogue it, we publish the spectroscopy, we update formation models, we wait for the next interstellar visitor to see if the pattern repeats. But if it doesn't, if the rotation state changed, if new spectral features appeared, if the trajectory bent, if the outgassing became directional, if radio emission occurred, if fragments separated, if JUICE saw something unexpected, if December observations diverge from October extrapolations, if the object does anything that requires adding non-natural terms to the dynamical model, then we're in uncharted territory. NASA's Planetary-Defense Coordination Office has coordinated asteroid response for 2 decades. The protocols are mature, track the object, calculate impact probability, model deflection options, communicate with international partners, inform decision makers. None of that applies here because 3I Atlas isn't on a collision course. It will miss Earth by 270 million kilometers. You can't deflect it. You can't intercept it. You can only watch. The activation of defense protocols in this context means something different. It means institutional acknowledgement that an interstellar object behaving anomalously warrants coordinated monitoring and contingency planning because we have no precedent, no baseline, and no certainty about what happens next. Representative Anna Paulina Luna sent a letter to NASA Interim Administrator Sean Duffy on the 31st of July 2025 requesting coordinated federal observation and risk assessment. That letter, publicly accessible, used language like black swan event and potential threat, and recommended treating 3I Atlas as a test case for protocols that don't yet exist. The IAWN announcement on October 21 followed. Not coincidence, not routine, a deliberate, documented, institutional response to an object that doesn't fit categories. Let's talk about the Oberth effect. It's not exotic physics, it's orbital mechanics. When you fire a rocket engine, the kinetic energy change depends on your velocity. Burn fuel while moving fast, and the same thrust produces more energy change than burning it while moving slow. Perihelion is where orbital velocity peaks. For 3I Atlas, that velocity reached 68 kilometers per second. An impulsive maneuver at perihelion maximizes efficiency. If you wanted to release probes that needed to slow down and enter inner system orbits, you'd do it there. You'd use the sun's gravity well like a slingshot in reverse. You'd separate packages with tiny velocity kicks that, amplified by months of differential solar gravity, diverge into completely different trajectories. From Earth's perspective, the mothership appears to continue its original path. The probes, with kicks measured in meters per second applied at perihelion, gradually peel away. By the time they're detectable as separate objects, they're already on independent courses. This is engineering, not speculation. Spacecraft do this routinely. Voyager, New Horizons, Cassini. O-berth maneuvers are standard astrodynamics. The question is whether 3I Atlas has engines. Probably not. But the remote possibility must be considered seriously because the consequences are enormous and the observational gap is real. 8 days, unobserved, 33 gigawatts of available solar power, optimal geometry, perfect timing. If something happened, if a maneuver occurred, if objects separated, we won't know until JUICE's data arrives or until ground telescopes see new trajectories diverging in December. The silence is the problem. The gap is the vulnerability. Scientific integrity demands we distinguish evidence from speculation. The evidence says 3I Atlas is chemically anomalous, geometrically unusual, and contextually suspicious. That's data. The speculation says it might be artificial. That's hypothesis. Testable. Falsifiable. We'll know more in 6 weeks when the object reappears and observations resume. Until then, we follow the evidence wherever it leads, we maintain skepticism as the default posture, and we prepare for outcomes that span the entire range, from mundane natural comet to something requiring a different vocabulary. Because here's the thing, we've now confirmed 3 interstellar objects in 8 years. 1I, Oumuamua in 2017, 2I, Borisov in 2019, 3I Atlas in 2025. If the detection rate stays constant and survey capacity improves as Vera Rubin comes fully online, we should find several per year within a decade. Each one is a data point. Each one tests models. Oumuamua was bizarre, tumbling at 8.6 hours, elongated like nothing natural, accelerating away from the sun with no visible outgassing. Borisov looked normal. Classic comet. Familiar spectroscopy. Expected behavior. Atlas is somewhere in between. Active but weird. Outgassing but in the wrong composition. Shaped like a comet but emitting like a factory. 3 objects. 3 profiles. 1 statistical sample is insufficient to draw conclusions, but sufficient to establish that interstellar space contains diversity. Things form differently elsewhere. Chemistry varies. Physics stays constant, but initial conditions span enormous parameter space. Stars explode with different metallicities. Protoplanetary disks have different carbon to oxygen ratios. Molecular clouds vary in density and temperature. Objects forged in those environments carry signatures of those origins. Or, alternatively, some objects are made rather than formed. We can't dismiss that possibility without evidence. We also can't assume it without evidence. The scientific method demands we hold both hypotheses simultaneously, weighted by probability, updating as data arrives. Right now, the probability that 3I Atlas is artificial is low. Maybe 5%, maybe 10%, not 0, not 50%. Somewhere in the range where responsible institutions activate monitoring protocols, not because threat is likely, but because failing to monitor when threat is possible constitutes dereliction. That's the calculus. To stay on the timeline as this unfolds, you'll need continuous access to observational updates and institutional announcements, because the next 6 weeks will determine whether 3I Atlas remains an astrophysical curiosity or escalates to something requiring global coordination. The JUICE observation on November 4, the IAWN campaign beginning November 27, the December reappearance and Earth close approach, the astrometric refinements in January, and the Jupiter encounter in March form a sequence of decision points. Each observation either narrows the hypothesis space or expands it. Each dataset either confirms natural origin or fails to. Subscribe now to ensure you don't miss the moment when the trajectory changes, or when the spectrum shifts, or when JUICE transmits images showing something unexpected. This isn't clickbait. This is a calendar of scheduled observations that will happen regardless of whether you pay attention, but you'll want to know the results immediately rather than reading summaries months later. The question we're actually asking is older than telescopes. Are we alone? Does intelligence arise elsewhere? If so, does it explore? Does it communicate? Does it visit? For decades, SETI listened to radio frequencies, assuming advanced civilizations broadcast. Nothing definitive emerged. Oumuamua suggested a different approach. Instead of signals, look for objects, physical artifacts, probes, debris, things traveling between stars that carry information in their structure or chemistry or behavior. If intelligence is common, interstellar space should contain evidence. If intelligence is rare, we'll find only natural objects forged in the chaos of stellar formation and ejected by gravitational interactions. 3 objects, insufficient statistics. But the third one emits nickel without iron, points a tail at the sun, arrives in the ecliptic plane, and transits perihelion during perfect observational blackout. Maybe it's a comet. Probably it's a comet. The safe money bets on comet. But the evidence accumulates. The November observations will matter. If 3I, Atlas, looks exactly as expected, we relax. If it looks different, we escalate. Until then, we watch, we measure, we calculate, we prepare, because the universe has sent us 3 visitors. The first was strange, the second was normal, the third is undecided. And we're about to find out which category it occupies. Contact or pattern seeking, signal or noise, technology or geology. Leave your assessment in the comments, because the data supporting either interpretation is real, the timeline is locked, and the observations are happening whether we're ready or not. The sky is not empty. Objects cross the space between stars. Some carry water and rock, some carry carbon and metal, and some might carry something else entirely. 3I, Atlas, is out there right now, accelerating back toward the outer solar system after its closest approach to the Sun. It glows in infrared, it emits nickel, it streams carbon dioxide into the vacuum. It follows a precisely calculable trajectory that will carry it past Venus on November 3, past Earth's orbit in December, past Jupiter in March, and then out into the eternal night beyond Neptune, beyond the Kuiper belt, beyond the heliopause, back into interstellar space where it came from, carrying whatever information it arrived with, leaving behind only spectroscopic signatures and astrometric residuals and a catalogue of anomalies that don't quite fit the models. We get one chance to study it, one pass, one set of observations, and we're taking it, because this is what science does. It looks, it measures, it questions, it tests, it follows evidence, even when the evidence points somewhere uncomfortable. It maintains rigor. It demands reproducibility. It updates beliefs when data requires updating, and holds firm when data supports existing models. 3I, Atlas, will tell us what it is. Not through intention, through observation, through spectra and trajectories and time series, photometry and radar echoes, and the accumulated weight of measurements that either converge on natural comet or diverge towards something requiring new terminology. Either outcome advances knowledge. Natural comet teaches us about interstellar chemistry, and planetary formation diversity. Artificial Object rewrites the human story and confirms we're not alone and raises 1,000 new questions about who built it and why, and whether it's the first or the 1,000th, and whether others are coming and what they want, and how we respond. But we don't get to choose which outcome occurs. We only get to choose whether we look. And we're looking right now, with every telescope we have, with every spectrum we can capture, with every data point we can extract from this brief window, while the object remains bright enough and close enough and positioned favorably enough to yield measurements that matter. The next 2 months will be historic, not because 3I Atlas will impact Earth. It won't. Not because it poses danger. It doesn't. But because it represents the first interstellar object anomalous enough to trigger institutional protocols designed for threats, even though the threat here is not kinetic impact but epistemological disruption, the threat is to our assumption that all comets are natural, that all objects are geology, that all visitors are accidents of gravitational dynamics rather than products of deliberate engineering. Maybe we're wrong to activate protocols. Maybe it's overreaction. Maybe December observations will show a perfectly normal comet that just happens to have unusual chemistry because it formed somewhere weird. Or maybe we're about to learn that the galaxy is far more interesting than we thought. Tune in, follow the observations, track the data releases, watch for JUICE's transmission in February, monitor the IAWN campaign results in January, check for December spectroscopy showing post-perihelion changes, because this story is still being written and the next chapter arrives in 6 weeks.